Hey everybody, what is up? This is Gabriel. So I wanted to show you something I have been working on called Muse. Muse is the domain-agnostic version control system for multidimensional state. So you can think about this like Git, but instead of treating a file as the smallest thing you can reason about, Muse understands the internal structure of your files, and that changes everything about what a conflict means. So to make this a bit more concrete, I'm going to use music because music is a perfect example of something that looks like a file, but is actually several completely independent things layered on top of each other. So for example, down here, melodic, rhythmic, harmonic, dynamic, and structural. So let's think about a MIDI file, for example. On disk, a MIDI file is one blob of bytes. But inside, there are at least 5 things that have nothing to do with each other. Number 1, you have melodic, the notes that are being played. So this is like the pitch and the duration of each one. Secondly, you have rhythmic, when those notes land in time, the groove and the syncopation. Next, you have harmonic. These are chord voicings, key changes, the tonal color. Next, you have dynamic. So this is like velocity and expression, how hard or how soft each note hits. And then lastly, you have structural. So this is tempo, time signature. This is the skeleton that the rest of everything else hangs on. And all of these are orthogonal axes. A drummer and a pianist can edit the same MIDI file, one touching only the rhythmic dimension and the other touching only the harmonic dimension, and there's no conflict between them. So they didn't touch the same thing, and Git would flag the whole file. And Muse resolves this in silence. And so that's the idea. Let me show you this demo. This is incredibly rad. All right, so as we get started here, let's look at the top. Here you can see we have 14 commits, 6 branches, 1 merge, 1 conflict resolved, and 41 operations. Everything you're about to see ran against a real Muse repository. So these are real Muse commits. These are real Muse branches. These are real SHA-256 content hashes. The whole demo took about 150 milliseconds to execute. So there's 14 commits, 6 branches, 1 merge conflict, all resolved. Let's walk through them all and see how this DAG got put together. All right, so Act 1. Muse init right here. So this is the command that got called, Muse init. And we start with an empty directory. So this is Muse init. It creates a .muse folder. Here you can see the path, initialize Muse directory, and this path, .muse. So this is a hidden .muse directory. It's at the repository root. It's content addressed object store, branch metadata, config file. It's the same idea as git init, but it's designed from scratch to be domain agnostic. In step 2, we have muse commit dash message root initial state snapshot. And then you can see we have main branch, a commit hash, and then a message. And then we have these tags here, and then the git hash and the time. And so this is the first commit. And notice in the dimension matrix, you can see them here. You can see them over here. If we hover on it, you can see them there as well. And then if we scroll down in the dimension matrix right here in this first commit, every single dimension lights up for this first commit. So you have melodic, harmonic, rhythmic, dynamic, and structural, all 5 of them, because this is the root, and we are establishing the baseline state for every dimension simultaneously. So under the hood, Muse calls muse plugin.snapshot, which walks the working directory, hashes every MIDI file with SHA-256, and returns a content addressed manifest. And then that manifest is what gets committed to the DAG. So then we have step 3. Boom. Muse commit m layer 1 add rhythmic. So now we add a layer. Looking at the dimension matrix, so if we go to the bottom, again, you can see it here. You can see it if I hover over it, rhythmic and structural. Again, you can see it here, rhythmic and structural, but you see it best in the matrix here, rhythmic and structural. So only rhythmic and structural light up. Rhythmic because we're adding a new rhythmic layer file. Structural because adding a file changes the shape of the snapshot. The melodic, harmonic, and dynamic dimensions, they remain untouched, and Muse understands that. So next. Boom. Muse commit dash M, layer 2, add harmonic dimension. Same pattern, harmonic and structural light up. So here you can see it here. If we come down here to the bottom, harmonic and structural light up. We're adding a harmonic layer. The rhythmic work from the previous commit is preserved exactly as it was. These are independent operations on independent dimensions. Next. Boom. We have Muse log dash dash one line. So this is a quick sanity check. 3 commits, linear history. We're on the main branch. This is the foundation, the musical canvas everyone will branch off of, right? So this is, we've laid our foundation. We've got 3 commits on our DAG. We've developed all 5 of the dimensions. Here we are. We did a Muse log. It gave us 3 brief one-liner commits. We know where we are. Good to go. All right. So here, now we're in Act 2, divergence. So here you can see the branches on this directed acyclic graph are about to diverge. There's going to be 3 of them. So the first thing we say is Muse checkout branch alpha. So we're creating an alpha branch. You can see it here. It's these ones. They say alpha, right? So first we're creating an alpha branch. We have 2 commit texture patterns. So the first one is sparse and the second one is dense. The first one is melodic and rhythmic dimension. Again, you can see it here on these colors. And if I scroll to the bottom, you can see it. Oh, sorry. Oop, how can I get there? Here we go. You can see it down here as well. And then, of course, you can see it if I hover it as well, melodic and rhythmic. A sparse arrangement, a few notes, lots of space. And then below that, we have melodic and dynamic dimensions down here. This is the dense version, more notes, more expression. So watch the dimension dots on the DAG. Each commit shows exactly which dimension it touched. Alpha is doing melodic work. So if we go through this, sorry. Those are the 2 alpha commits there. Here again, you can see melodic and rhythmic. Alpha texture pattern A sparse, and then the next commit is alpha texture pattern B, and it's melodic and dynamic. Okay, good. Next, steps 9 through 11. Just make sure we're there. Boom, step 9. Back to main. So here we say Muse checkout main. So we're going back to the main branch. And then Muse checkout beta B. That's the next step. Boom. So we're checking out a new branch called beta. So we went back to main and we checked out the beta branch. This is the green one, right? So this is the green branch here. Got this commit here. And then we say gamma ascending melody A. Oh, I'm sorry, this is the gamma branch. This is the B. So here we say we have a commit beta syncopated rhythm pattern. So this is rhythmic and dynamic dimensions, right? And we can see this here. And then if we go down to the bottom, we can see it here too, rhythmic and dynamic, right? Right here. And so let's find it again. And so beta is a completely different musical idea. It's not touching melody at all. It's just a rhythmic section working in its own lane, rhythmic and dynamic only. So then we go to steps 12. Step 12, I mean. And this is the gamma branch. So this is the purple branch down here. And this is interesting because you can see it branches off up here and it goes down here, but then it doesn't reconnect. So what's going in there? We'll find out here in a second. So first we do back to main. Then we do Muse checkout B gamma. So now we have a gamma branch. Then we have a new commit here. This is purely a melodic dimension. We call this ascending melody A. And then we have another commit here. This is a descending melody B, right? So we just create a new branch. We're trying some different melodies. This is ascending. This is descending. Okay, good to go. Now, next, step 16 is Muse log, one line. So again, right here, scroll up a little bit, right here. So 3 parallel stories. Alpha is building texture. Beta is building rhythm. Gamma is building melody. None of them know about each other. The DAG is starting to look like a real project. Now we move into Act 3, the clean merges. Okay, now we bring it together. This is the part that's usually painful in Git. In Muse, it's going to be boring, and that's the whole point about what makes this special. So, first, step 17. Merge alpha into main. So Muse checkout main, then Muse merge alpha. The output says fast forward to, and then it gives us this hash. Alpha was strictly ahead of main, no divergences. Fast forward, 0 conflicts. Step 19, Muse status. Nothing to commit, working tree clean. Main now has all of alpha's work. Step 20, merge beta into main. Muse merge beta. This one creates a real merge conflict. Merged beta into main. What happened under the hood, right here, what happened under the hood, Muse found the common ancestor, the layer 2 commit, computed the three-way delta, and asked, did the same dimension change on both sides? Alpha touched melodic and dynamic, beta touched rhythmic and dynamic changed on both sides. In Git, conflict. In Muse, the dynamic changes are in different files, so the union is clean. Merge commit, no human intervention, done. Step 21, Muse log. One line. The DAG shows the merge. Main now contains the work of 3 contributions. Clean. Boom. Let's keep going. Next. 22. Conflict and resolution. Now we're going to manufacture a real conflict. 2 branches are going to modify the same file on the same dimension. This is where Muse shows what makes it different. So Muse checkout B, steps 24. Let's go to it. Right here. Wait, sorry. 22. That's where I want to be. My bad. There we go. So Muse checkout B, a branch, conflict left, commit. Left introduce shared state version A. This branch adds shared state MIDI file and edits it with a melodic approach and structural change. Okay? Now, step 24, back to main, right? Then check out this branch, switch to this branch, conflict right, commit, introduce shared right stage, version B. Got it? So far, so good. Both conflict. Here, let's go down here to this right here. This is the conflict, right? So we actually do have a conflict now in the same dimension across the same file. So this is interesting. The left touched the melodic and structure, the right touched harmonic and structure. The structure appears on both sides. That's the conflict. Step 27, merge conflict left, fast forward clean. Step 29, so that's that. Step 28, fast forward clean. Step 29, merge conflict in one file. Here we go. Conflict, both modified, shared state.midi, right? We see this right here. This is where we're at. So if I scroll up a little bit, here we see it. Merge conflict in one file. Conflict, both modified, shared state.midi. Fix conflicts and run Muse commit to complete the, and then it says merge there. Okay, so here it is. In Git, you'd open the file, see angle bracket markers, and try to figure out what their version of a binary MIDI file even means. And so I would say good luck with that. In Muse, the merge engine already knows which dimensions conflicted. It ran muse plugin.merge with repo root set, which one loaded the Muse attributes file, so it checks for strategy rules. Number 2, it calls merge MIDI dimensions on the shared state MIDI file. Number 3, it extracts the 5 dimension slices from bass, left, and right. Number 4, it compares them. Melodic only changed on the left, harmonic only changed on the right, structural changed on both. Number 5, auto-merged melodic from left, auto-merged harmonic from right. Number 6, flagged structural as the one dimension that needs a decision. Pointed to the red. Let's see here. Hold up. I'm trying to read my notes. So again, I already showed you guys where it is down here. This is the merge. And so, hold on one second. I'm finding my notes. Yeah. So one dimension conflicted, 4 resolved automatically. Git would have thrown the entire file at you. So now let's see how it's resolved. Let's scroll up a little bit. Boom. Here. The human makes a decision on the structural dimension and commits resolve, integrated shared state, A plus B reconciled. So, again, you want to look at the dimensional matrix. Only one structural lights up. That's the exact scope of what was resolved. The merge result carries applied strategies and dimension reports that document exactly what dimension was manually resolved and which were auto-merged. And then next, we have Muse status, nothing to commit, working tree clean. The conflict is history. Literally in the DAG, it's attributed, audited, and permanent. And now we have advanced operations. So now we're going to show that Muse has the full surface area you'd expect from a modern version control system. So right off the bat, this is subtle, but it's one of the most important things Muse demonstrates. So watch this out, check this out. So here we have Muse cherry pick, and we're grabbing the ascending melody, right? Remember I told you we created this gamma branch, but we didn't merge it anywhere. What are we going to do with it? Now down here, we're going to cherry pick just the ascending melody and put it in here, right? And replay it on top of main. This is an audition. We're not merging gamma, we're borrowing one idea from it. Notice this cherry pick has no structural connection to gamma in the DAG. There's no line here, right? It's a content copy, a new commit with a new hash parented to main's head. Gamma doesn't know it happened. The two commits are not linked by an edge on the graph. So then we have Muse show right here. We expect what actually changed. Then we have Muse diff. No diff, working tree is clean, the ID is in, then we listen to it, then we stash it, Muse stash pop. So you can see we can, sorry, I lost the button, where's it at? There we go. So you can say Muse stash pop, we can say Muse revert, right? So the ascending melody doesn't work, we didn't like it, get rid of it. And so this is interesting because look at what just happened in the DAG. There are now two commits sitting between the resolve and the tag. One that says, here's the melody, one that says, never mind. Both are permanent, both are in the history forever. That is not a mistake, that is the point. 6 months from now, right? 6 months from now when someone says, did we ever try a melody in this section? The answer is in the DAG. Yes, it's on this date. Here's exactly what it was, and here's the explicit decision to reject it. You can check it out, listen to it, and put it back if you change your mind. So the descending melody B commit on gamma B, it's still there too, right here. Never used, never merged, never deleted. Muse doesn't garbage collect ideas. The entire creative history of the project, including the roads not taken, is preserved forever in the DAG. All right, so now step 39. We're going to add a tag, right? Add release version 1. Then Muse tag list, it lists the tag. Then we got Muse log stat, full log with file level stats for every commit, the entire history of this project, 14 commits, 6 branches, 1 real conflict resolved, etc. If we scroll down, again, you got the dimension matrix. And then here at the bottom, we just have simple how does Muse work. You can see that it's very modular. We have Muse CLI, which is just like what you would expect, Muse emit, Muse commit, Muse log, etc. Everything we just saw there. You have your plugin registry. We have a core engine. We give you the DAG, the content addressed objects, the branches, the store, the log graph, the merge base. We do all this for you. All you have to do is implement these 5 methods: snapshot, diff, merge, drift, apply, and you can have any domain and plug it in. So we have music, but what about a genomics plugin? What about a space-time plugin? What about your project? If you have structured data, and you do, then you could use Muse to create a domain-agnostic version control for multidimensional state. And so that is the demo of Muse. You can go check it out right now. It's on GitHub, cgcardona/Muse. It's available under the MIT license. Let me know if you guys have any questions. Thank you so much. Peace.